Okay. So lesson 1, chapter 4, page 96. If you're looking for page number, so page you have 96, and lesson you have the first lesson. The name of the lesson we have it is about the climates. Right? The lesson is climates. Okay. Now, at the start of the lesson, we have some key questions. Which the first question is, what is climate? And the second point is, what factors determine global climate? So these two main points we will discuss in this lesson. At the end of the lesson, you will be able to differentiate between weather and climates. At the end of the lesson, you will be able to do what? You will be able to differentiate between weather and climates. And you can easily identify the factor that influence climate, mean that change the climates. So at the end of this lesson, you will be able to do this too. First of all, what is weather and climate? Who can define for me weather and who can define for me climates? Anyone who can, please.
Uh, can I?
Yes, please.
Okay, weather is in a short period of time, and climate is in a long period of time.
It's good. Okay, now weather, the first one, we have weather, day-to-day condition of the Earth atmosphere, right? The condition of the Earth atmosphere. So it can be changed from one region of the world to another region, right? Day-to-day conditions, it can be changed from one place to another place and from one day to another day. It can vary between days and it can vary between places. While if you're talking about climates, so climates are not the short term, right? Climates are not day to day, week to week. Climates are long term patterns of temperature and precipitation over many years, right? Not over 1, 2, 3 days, not over 1, 2, 3 weeks, not over a month or two, right? It is a pattern of temperature and precipitations which occurs over many years, right? So there is the difference that weather is day-to-day changes, day-to-day variations, place-to-place variation, and climates will be for long terms, right? Long-term pattern of temperature and precipitation mean for many years, right? And even in the climates, right, it will also it depends on what it will depend also depend on the places or region, right? For a long region, it can be there. Who is in the lobby? Okay. It is important to note that climate is rarely uniform even within a region. Climates will be uniform in a specific region, right? Within any region. Environmental condition can vary over a small distance, but if you're talking about environmental condition, so environmental condition, it can vary over a small distance, and then it is going to create a microclimates, right? Like for example, the example of the microclimate is, if you take an example of northern hemisphere, place plant in the northern hemisphere. So in the northern hemispheres, the same plant, the south facing side of the trees and buildings receive what? Receive more sunlight. And the other sides often warmer and drier than the north facing side. So the one side is what? One side which is toward the north. It will be what? It will receive more light, while the one which is toward, the south facing side will receive more light, while the north facing side it will receive less light, right? So it is an example of microclimate. Now about example about weather and climates, right? If you look here in this region of the world in which we are living, right? In these places, how you can give me example from let's suppose from last 1 month about the weather and about the climate. Who can give me example about the weather and about the climate from previous, let's suppose 1 month, for two, for both, for weather and for climate, please.
Could I?
Yes.
An example for a climate is like in Saudi Arabia, on how we live in a desert and it's mostly hot, and there's like uh, one day or a couple of days in a year where it starts raining. That's
Yeah.
an example to the weather.
That is an example of weather accident about climates.
Yeah, and when it rains and the weather becomes slightly colder, like dropping below 10, sometimes that's an example of the weather.
Okay. Now, from if you look the weather, right? If you talk about the weather in the place we are living, right, in Saudi Arabia or in Riyadh, we are saying. So, look here. If you look to the temperature here, right? So mostly we are living in high temperature, right? High temperature means that the temperature throughout the year, except 1 month, 20 days, 25 days, right? It remain under 10 or near to 10, right? 7, 8, 13, 14. But if we look throughout the year, so the temperature remains in 25, between 25 and 50, right? Like let's suppose just rewind back 25 days, mean in January 15. In January 15, the temperature fall down to 5 or 6, right? But now if you look back, today we have what? Today we have 15, 16 date, right? So if you look back after 1 month, so after 1 month we have temperature again 25 plus, right? So only this short period of time, which is just around about 25 days or 30 days, right? If you look back to 7, 8 date of the January, right? So 7, 8 date of the January, we are having 22 temperature. So I mean it was also then rise. So just a short period of time, for 15 days or for 20 days, we feel cool weather, right? But rest of the year, we are facing moderate weather, right? Which is 25 to 50, right? That is weather, right? We change. And if you look today, yesterday we were having a very warm day, right? In which the temperature was around about 24 to 27, right? But today at morning, when you see the temperature was dropped down to 18, 19, to today, the weather was cool as compared to the yesterday. Most probably today, the same we will have. And about the climates, so if you look to the climates, the long-term changes, right? The climates, right? So if you look in this part of the world, we do not have too much rains, right? We do not have too much rains. Exceptional we have, like this last 15, 20 days, it's exception. We have a lot of rains, right? We receive around about 10 days rain, but most of the time in these regions in which we are living, it do not have rain, right? So that is about the example for long-term climates, right? And if you look to the temperature, so temperature throughout the year, it will remain for what? It will remain high, right? But if you compare this temperature with South Korea or Canada or some part of the Asia even, so they have cool temperature, right? Their temperatures will not go above 10, and our temperature is not going below 10, right? So that is a climate change for these places. Now the next point which we are going to take, it is the factors they are going to affect climate. The factors they are going to affect the climate. So certain factors, we have many factors, but two, three factors I think are given in the book, which are solar energy, trap in the biospheres, latitude, and the transport of heat by winds and ocean currents. So these are three, four factors which is given in your book. We will take it, right? What factors determine global climates? A person living in Orlando, Florida may wear shorts and t-shirt in December, while someone in Minneapolis and Minnesota is still wearing a heavy coat in April, right? Let's suppose take the example of Saudi Arabia and the example of Canada or South Korea, right? So if you look in Saudi Arabia in February, in November, and even in December and January, we are not using too much heavy clothes, heavy dresses, right? Because of what? Because the temperature here, which we are facing, it is average 20 down, right? In December and January, that is down temperature, that is cool temperature. But if you look at the temperature in February, March, April, May, June, July, August, September, October, November, so it will be in between 25 and 15, right? So then we are using light dresses. Why? Because we are facing very high temperature. But if you look back to North Korea, right, or to Canada, right, or to any frozen places, so their temperature is ranging in between 0 to 10, right, or minus 10 to 10. So then they are using what? They are using heavy dresses to protect themselves from what? From the cold. Clear? What causes difference in climates? So global climate is shaped by many factors. What causes difference in climate? So there we have many factors, right? Some of them which we are going to count, some of them which we are going to discuss, right? So the most important one is including solar energy trapped in the biospheres, right? And the solar energy, how it reaches the earth. Latitude mean where a place is present, right, on the polar, on the pole, or either on the equators, and transport of heat by winds and oceans from the equator to the poles, how the heat is transported to other part of the world. So all these factors are affected one by one. We will take it: latitude, solar energy trapped in the biosphere, and transport of heat energy and moisture, how heat energy is transferred from one place to another place, and geographic features, but this is not given in your book, right? Okay, the first point which we are going to take, that is solar energy and the greenhouse effect. Solar energy and the greenhouse effect, that is the first point we are going to take. The main force that shape our climate is solar energy that arrive as a sunlight and strike the earth's surface. So the main source of energy for the earth is what? It is sunlight, right? So it will be what? The sunlight energy, it will strike the surface of the earth, right? So when it strikes the surface of the earth, what will happen? Some of the energy is reflected back into the space, and some is absorbed and converted into heat. Some of that energy which come from the sun and strike the surface of the ground or strike the surface of the earth, right? So some of that energy will be absorbed by the earth, and some of that energy will be reflected back to the space, right? Some of that heat is turned radiated back into the space. The heat which is the energy which is absorbed and it radiates in the form of heat. So some heat will go back to the space, right? And some of the heat is turned radiant back into the space, and some is trapped in the biosphere. So some heat is returned back to the space, and some of that heat is what? Some of that heat is trapped in the biosphere. The balance between heat that stay in the biospheres and the heat lost to space determine Earth average temperature. So the heat which is returned back to the atmosphere or which is radiated back to the atmosphere, and the heat which remain in the biosphere, right? The balance between heat that stay in the biospheres and the heat lost to the space, both of these are going to determine the Earth average temperature. So it will determine what? It will determine the Earth average temperature. This balance is largely controlled by the concentration of three gases found in the atmosphere. So this balance is controlled, or we can say determined, by what? The concentration of three gases, which is carbon dioxide, methane, and water vapor. These are the three gases which determine the concentration, or which control the concentration, which control the balance of these gases, right, in the atmosphere. Diagrammatically, you can see it here. Here you can see this is sunlight, the source of sunlight. So when the sunlight is going to strike the surface of the earth, let's suppose the sunlight strike the surface of the earth. So some heat is going to reflect back to the, right? It is going to reflect back to the upper atmosphere. You can see this, right? Some of the heat will be absorbed by the earth, After the absorption of the earth, it will radiate, some of the heat will be radiated back to the space, right? And the radiated back to the earth and absorbed or retained in the atmosphere, right? So it will be retained or regained and the reabsorbed in the atmosphere again. Latitude in solar energy. The next point, the next factor affecting the climates, that is latitude and solar energy. If you have any question till yet, you can ask me. Okay, no questions, so we will move to the next question, to the next part. Latitude in solar energy. Near the equator, solar energy is intense as the sun is almost directly overhead at noon all the years. If you look here in this part of the earth, mostly we are near to the equator, right? So at the noon, in the noon, you can see all the time the sun is directly. So it is intense too much here, right? That is why equatorial region are generally warm. So those places which are near to the equator or which are on the equator, so they are what? They are generally warm places, which you will see in the figure on the next slide. The curvature of the earth caused the same amount of solar energy to spread out over a much larger area near the poles than near the equator. So if you look to the curvature, earth causes the same amount of solar energy to spread out over a much larger area near the poles than near the equator. Thus, Earth polar area annually receive less intense solar energy and therefore heat from the sun. So if you look here, so the Earth polar area annually it receives less intense solar energy and therefore also the heat from the sun. This difference in the heat distribution create three different climates. So on the base of distribution of the heat, we have three different climatic zones. One is tropical zone, other is temperate zone, and other is polar zone. Tropical zone, temperate zone, and polar zone. These three zones we have, right? First, you can see the one which is polar zone, right? So it will be less direct, right? It will be less direct, and the one which is temperate region, so it will be like in between both of them, and the one which is on the tropic level, so mostly it will be direct, right? You can see climate zone, earth climate zones are produced by unequal distribution of the sun heat on the earth's surface. Polar region receive less solar energy, right? So when you look to the pole, so pole will receive less solar energy, right, per unit area, and the less heat than the tropical region do. The tilt of the heat axis causes the distribution of the sunlight to change over the course of the year, right? So that was about the climate zone. The greenhouse effect we have already studied before. So greenhouse effect, you can see energy enter as a light to the greenhouse, right? Much of the energy is trapped as a heat. So most of the energy it will be trapped in the form of the heat. And smaller amount of the energy passes back through the wall. So most of the energy will remain inside the greenhouse, right? And we call the effect which is going to create, which it's going to create, we called it greenhouse effect. Clear? Okay, so this you already did, right? This is about how the sun comes. reflected, absorbed, radiated, and retained. Okay, this we also finished. Okay, the last point which we are going to discuss, it is about the latitude and the solar. Sorry, this the last point we have is about the heat, transport, and the biosphere. The next page, right? The last page of the lesson. Unequal heating of the Earth's surface cause wind and ocean currents. So if you look the Earth's surface, so they have unequal heating of the Earth's surface, which is going to cause wind and ocean current. Wind and currents move heat through the biosphere. So with the help of the wind and with the help of the current of the oceans, it move or it take away heat from one place to another place. The unequal distribution of the heat occurs. The globe creates wind and ocean current which transport heat and moisture. The same point which we explained before. Earth has wind because warm air is less dense and rise. So if you look to the Earth, it has wind, right? And the warm air is less dense and it will rise from the surface of the Earth a bit. And the cool air is more dense and it sinks, so it will come down to the Earth's surface. For this reason, air that is heated by a warm area of the Earth's surfaces, such air near the equator, for example, rises. So if you look to near the equator, the air will be warm, so it will rise above, right? It will not sink because it has low density. As this warm air rises, it expands and spreads. As the air is warm, right? So it will rise. And if it's rise, so it will expand and it will do what? It will spread. North and south, in both the direction it will spread, right? Losing heat along the way. So when it's traveling to the north and south, so it will lose heat with the passage of time. As it is going to cool down, the air sinks. So with the passage of time, it is going to cool down, so it will get more density. Its density will increase, and it will come down. At the same time, in cooler regions, opposite to this, so at the same time, in the cooler region near the pole, chilled air sink toward the Earth's surface. So if it is cool, it will have more density, it will sink down. Okay? Pushing air at the surface outward. So it will pushing the air at the surface outward, right? This is all about the heat transport in the biospheres. In this way, the heat is going to transport in the biosphere. Warm air, it will always rise. Cooled air will always sink. So rising air masses lose the heat. So when the air is going to rise and it is going to float, it is going to expand, it will do what? It will lose the heat and then back it will come to the surface, to the ground. Mean it will get more density, it will come down in that sense. Right? You can see here.
Sorry, my Wi-Fi disconnected.
It's okay.
Thank you.
Okay, so this was all about today's lesson. If anyone has any doubt, so you can ask me. Here you have an overview. The greenhouse is what? Greenhouse, it's trap heat in the biosphere. And some of the energy that enter Earth atmospheres is radiated as a heat. So this was all about the lesson about climate, right? Lesson 1, we started on page number 96 and we finished on page number 98. If anyone has any type of doubt, any type of question, so you can ask.